Okay, everyone. Um, Exam number 3. I hope you read my email over the weekend. Is this coming Thursday? I'll be there at 6 o'clock. Same old scientific calculator, no notes, but you can certainly do a brain dump. You can get there early and wait a little bit of time and study before you take it. That's totally up to you. I plan to be there until at least 9:30 at night. Okay, so you've plenty of time, relax. I'm hoping that tonight and tomorrow night will be nothing but review questions. Nothing. So if you guys have questions and we keep asking them all night long, that's great. That's wonderful. I'll keep doing that as long as we can all night long. I suppose I should be looking at the camera instead of the stupid computer, but so if you ask the questions, I'll answer everything. I'll do your homework for you. I'll do whatever you need me to do. I suggested that you take notes from the quizzes that you took on ones that you struggled with, because those are probably going to be the same ones that you're going to struggle with on the test. Okay. I just was doing a real quick look at item analysis on the test to figure out, okay, which problem did you guys miss the most? And real quick, I have 3 problems I want to do off of the quizzes, but then I'll open it up to any questions you have. Okay, so bear with me on this, please. Quiz number 1. I forget what problem it was. I didn't write that down, but it said something like f of x is x squared plus 8x. G of x is x minus 8. And then the first part was find f circle g. Okay, guaranteed question on the exam, guaranteed. So f circle g is the same thing as f of g of x. Okay, even though we say f circle g or f composed with g, the g goes, whatever was on the right side goes in the middle. So what's g of x actually worth? Well, that's f of x minus 8. G of x and x minus 8 are the same thing. Okay, now, no pun intended, or maybe it is, but how do you f something? According to this rule, how do you f it? Well, f something says whatever you give me, I'm going to square it, and then I'm going to add 8 times it. It meaning whatever you give me. So I'm giving it this. This is what I'm giving it. This is what I'm plugging in. So according to the rule, it says I'm going to square it, add 8 times it, and then simplify. Okay, so that's a first step. Now I'm going to finish this off because I can see a major place where people could get screwed up, but that's the basic idea. The rest of this is just simplifying an algebra. F circle G is f of g of x, meaning you put g into f. So there's g in a different form. I'm going to put it into f. What happens when I put it into f? I square the sucker and add 8 times the sucker. Okay, so are we okay to this point? Okay, now I'm wondering how many people, when they squared this, called this x squared plus 64. How many people just squared the x squared the 8? You can't do that. Because of the minus, the pluses and minuses in there, to do x minus 8 squared, you have to go x minus 8 times x minus 8. And you have to go over and do one of those matrix boxes or whatever you learned. But this becomes x squared minus 16x plus 64. plus, this becomes 8x minus 64. And so when you combine like terms, you get x squared minus 8x. And this is just simply the answer. Okay, what do you get when you stick this problem inside of this problem? Blah. You're not solving it. There's no equal sign anywhere. It's just, this is the arithmetic we go through. That would have been the answer. Is that okay with everybody or not okay?
Yes.
Okay. Now, the second half of this problem, same problem, was G circle F. Okay, reverse. So that's G of F of X. So now you're sticking F into the G function. So what is F? F is X squared plus 8X. So you're sticking in the G function. What's that say? The G function says, whatever you stick into me, I'm going to take it, whatever you give me, and subtract 8. So for example, if I put 5 in, I do 5 minus 8. If I put 51 in, I do 51 minus 8. If I put this in, I'll put this minus 8. Oops. Minus 8. And that's my answer. It doesn't simplify any further. And I'm done. Okay. So those are two problems that I took off of quiz 1 related to function composition. Guaranteed, that's probably going to be the first question on the test. I'll give you two functions and ask you to compose one with the other. F composed with G, G composed with F. Okay, so right there, problem, I'm trying to remember. I wrote the test a couple of weeks ago and I don't remember it, but probably the first two questions. Okay, I'd like to erase the board and two more questions from your quiz. Is this okay? Anybody taking notes? Anybody have questions about it? Okay, don't hear anybody yelling. Then off of quiz number 2, this is problem number 16. I understand the confusion. 2 to the K, it said solve. I'm sorry, I should have put the directions up. 2 to the K equals 1890. Now, the directions I can see confused you because it said use change of base. Okay, well, let me show you what they're talking about. And then let me tell you that I'm going to give you a problem very similar to this. Okay, and I'm just going to say solve. And I don't care how you solve it. We've talked about at least 2 different ways, but I'm going to show you how we solve it. Using the drawbar rule. Okay, this becomes log base 2 of 1890 equals K. That, remember, the drawbar rule is the definition of a logarithm. It's what allows you to go from exponential equation to a logarithmic equation. Okay, exponential to logarithmic. Now, Some of you, your calculator will do that. You have a button on your calculator, log base blank of blank, and your calculator do that. The change of base formula says if you don't have that magic button, then you can write this as the log of 1890 divided by the log of 2 with the assumption that the base is 10. So you can take this apart. So if you don't have the magic button on your calculator, you can take this base 2 problem apart and write it as 2 different base 10 problems, and then let your calculator do that work. Again, when it comes to exam number 3, I'm going to give you this problem. This is a guaranteed, and ask you to solve it. Whether you use change of base, whether you use the magic formula, or whether you use a different thing altogether, doesn't matter to me. Okay, I'm going to solve this another way. What answer do I get here? Clear. Okay. So however I do it, I get 10.88417 equals K. And I didn't see where it said to round, I don't, whatever, but if you can do that, that's fine. Again, on the exam, if you can take this and solve it to this, I'm delighted. That's it. Did the green show up? Just barely. All right. Before I open it up to questions for this problem, there's one more I wanted to do from the quizzes, but there's an alternate way that we've done this. Okay. The alternate way, instead of using the Bra-Bar rule, which is fine. I use the Bra-Bar rule just all the time for everything. Okay. You could take the ln of this side once you've taken the ln, which is a form of a logarithm, you can bring the power down. So this is k times the ln of 2 equals the ln of 1890. Divide both sides by ln of 2. And we get k equals the ln of 1890 over the ln of 2. And I promise you that if you pop all that crud into your calculator, you'll get exactly the same answer. So there's 2 different ways that you could attack this problem. Use the Bra-Bar rule to change it from exponential to logarithmic, or take the ln of both sides and use your log laws to bring the power down, the k down in front. Okay, questions on that problem? That was, it said 75% of the people got that one right, which means 25% of the people missed it. Okay, so that was worth talking about. Questions on number 16 from quiz number 2. Okay, the next commonly missed problem was quiz number 17 from quiz number 2. Question number 17 from quiz number 2. Come on, Foster, learn to talk. Yeah, I think that was it. Okay, now 800 times 1.19 raised to the t power equals 14,520. Okay. The math teacher in me says there is no difference between this problem and this problem. Actually, that's a lie. There's a subtle difference. We want to get this alone. See how this problem was 2 to the k and there's nothing else? And then we can start doing all of our magic log crud. So 2 to the k, get that alone. So that means on this problem, I have to divide both sides by 800. So that I can get the 1.19 to the t power by itself. Okay, and I don't know what that is, 1452. Come on, stupid, turn it on.
363 over 20.
I can see what I just could see what happens. I get 18.15. I already know that because of all the decimals, I'm going to have to use my calculator. So I just may as well go to, instead of reducing it, but you're right. Okay, you could reduce it as a fraction. If I got to use my calculator, I'm just going to say, screw it, just use decimals everywhere, let the calculator deal with it. Okay, that's why God invented calculators, because God hates decimals and fractions. Okay, trust me. So yeah, you could use the fraction, or you could just say this is 18.15. Should be the same thing. Okay, now truly this problem here, no lie, and this problem here are now exactly the same. I could apply the Bra-Bar rule, or I could do the LN to both sides. It doesn't matter. Okay. Do you guys need me to finish this one off? Do you want me to do the Bra-Bar rule or the LN to both sides? Or do you guys kind of follow how this one, after you divide out the 800, this problem and this problem are exactly the same? Anybody have any questions or comments on that one?
I got a question.
Sure.
So when it's in exponent form, do you change it to the bar? For the bar rule. So exponent form is the BRA, and then you change it to the bar.
It's not okay. I don't know how to answer this. It's okay. I could just as easily have called this the bar-bra rule. The name, okay, I said bar-bra, or this could have been the bar-bra rule. Okay, or it could have been the bra-bar rule. They're the same rule. What they do, if you have log base b of r equals a, of a equals r. If you have a logarithmic equation, log base b of a equals r, it's equivalent to the exponential equation b to the r equals a. So the letters don't matter. It's the pattern that the letters make. So this is your base, okay? This is your r. Okay, this is an exponential equation. So when you compare it to this is your base, okay? This is your r, this is your a. When you move it back into this form, it will become log base 1.19 of 18.15 equals t. The B, the A, the R, it doesn't matter. It matters how they match this pattern. Okay, I'm not sure I'm explaining that correctly. But all the bra-bar rule allows you to do is change it from one form into another form. So this was exponential, so I changed it back to logarithmic. So okay, ask your question again. I don't know how to answer it cleanly.
That's okay. I think I just get like, I think I need to study a little bit more because sometimes I don't know when to switch, like what pattern to use, like with logs, like when you turn the log to the exponent, like, oh, which one do I do? Do I use the bra method or like?
Okay, that's a fair question. Now I begin to understand what you're saying. Okay. And the first thing I would do if I get your test is I would write on that blank sheet of paper the bra-bar rule. Okay. And it looks like if you have B to the R equals A, if you have that pattern, B to the R equals A, which is what that is. Okay. That can be turned into, okay, log. Now, the base of the log of the exponent is the base of the logarithm. Okay. One of the things I said is okay, how do I do this? This is the A equals R. One of the things I've said is the logarithm. The day I first introduced this, I said a logarithm is an exponent. A logarithm equals the weird exponent. So the logarithm equals the exponent, the exponent, the exponent. So you need to write this formula on your paper and say, oh, this is an exponential equation. This is this. I want this to turn into this. Okay. Because the answer is, I don't know how to solve this. I don't know how to get t alone. So instead, we can say this is log base 1.19 of 1815, okay, equals a logarithm equals the exponent equals the t. So this is the pattern that allows you to change it from one form to the other. If this is the same formula, it's the pattern that the letters make. It's not that they spell bar or bra or anything like this. So if you have a log of a base, the base is the base, and the logarithm equals the exponent. So that's the exponent, that's the exponent. Okay, and so there's only one place for the R to go, which is right there. So yeah, you do need to practice that, but I would write, this is the same rule, just written forwards and backwards. So I would write that on your brain dump paper. That's rule number one. Does that clarify anything at all, or did I just make it worse, or I'm not making it better?
No, you actually helped with the log equals the exponent. That kind of helps me remember where to put the numbers.
Okay, the logarithm, okay, two things in, good. The base is the base. The base of the exponent is the base of the log, whatever you're doing. And the logarithm equals the exponent. So that it equals whatever the exponent was there. So good, write that down right now in your notes. Take a second to write that down, and then put it on a 3x5 card, and then when you get ready for the test, do a brain dump, put it right on your paper. Okay.
Thank you.
Yeah. Okay, anybody else? Any questions at all from anything? I got a bunch of things, but I want to make this your evening. I want to answer all the questions you have. None, huh? Okay. Then
Hey, Professor, can you kind of like a review for the faster way we find out on the graph that's a function or not? I remember you told us the one easy way, just like a imaginary line. Then you find out like one line only got one dot on the actual line on the graph. That right? That
right.
sounds right.
That's it. It's called a vertical line, not a
Okay.
horizontal line, but a vertical line. Yeah. And so that brings me, I was going to do that one right away, but we can do that.
Okay.
Suppose I have, okay, here's a test question for those of you paying attention. Okay, so here is a picture. First question to answer your question, is this a function? And the answer is, if you can pass a vertical line over the graph, okay, and it hits only one point at a time, it's a function. Okay, so yes, this is a function. It hits only one point at a time. Okay, what's the domain of this function?
Is it -5 to 4?
-5 bracket to 4 bracket. Because domain means all possible x's. And so from -5, every single x is being used up to 4. Okay, good. Range, anybody?
-1 to 0.
Nope.
-1 and 4.
-1 up to 4. Good. Because range means the y values. So the y values are going up and down. So the lowest y is -1, and it covers everything up to 4, which is the tallest y, -1 to 4. Yes or no? Okay, now, can you sketch the inverse of this function? Can you sketch the inverse? I'll pause for about a minute. All right, the key is in the inverse function, all of the x's get swapped with all of the y's, swap or switch. So if we start over here, -5, -1 will become -1, -5. That point, its inverse is that point. You swap or switch the x with the y's. Now, 0, 4 will go to 4, 0. So this is 4, 0. And they connect. Because these connect, these connect. All right. 0, 4 goes to 2, 4. But the inverse of 2, 4 is 4, 2. Which is like right about there. Okay. And on the black graph, 2, 4 goes to 4, 0. Okay. But the inverse of 4, 0 is 0, 4, which is right there, and they connect back that way. So the red graph is a sketch of the inverse of the black graph. Okay, and all I did was swap my x's and my y's and connect the dots in order. Now, the question is, the original graph, the black graph, okay, was a function. It passed the vertical line test. Yeah. Is the inverse a function? Is the
No.
red graph? No, because, okay, you go, yeah. Oh, right there, I'm hitting 2 points at a time. Okay. And therefore, when you hit more than 1 point, it's not a function. So the inverse is not a function in this case. In some cases it is, in some cases it isn't. That okay with everybody? There is bingo right there. Test question. I'll give you the picture of a function, ask you questions about its domain and range and stuff, and ask you to sketch its inverse. Questions, anybody? Okay. Then sketching its inverse is a pretty good thing, but can you actually find the inverse formula? For example, suppose I told you that f of x was 3x minus 4. Could you find f inverse of x? In other words, the formula. Could you develop the formula? Okay, so I'll pause while you think about that. I'll do it, but I want you to think about it. So the rules were, the rules were change f of x into y, the algorithm, the steps. So y equals 3x minus 4. Then swap the x and the y. Whether we swap the x and the y for the graph or swap the x and the y for the formula, it doesn't matter. We swap the x's and y's. And then we said solve for the new y value. So get y alone. So we would add 4. Then we divide everybody by 3. And I made a big deal that this just isn't any old function. This is the inverse function. And so I insisted and will insist that you say this is f inverse. This is not just any old dumb function. This is the inverse of the original function. They're special. They're related to each other. Okay. Guaranteed. Question. Now, check your notes. Make sure you remember the rules. To find the inverse, I just gave you some general rules. I said, replace the f of x with a y. And I said, swap the X and the Y. And then I said, solve for the new Y, get Y somehow alone. Okay, which we did. And it was pretty easy when it was a linear equation, when it's something we've been working with. But what if I gave you this? G of X equals 2 to the X. And I said, find its inverse. Find G inverse of X. And again, I guarantee a question similar to this on the exam. So a question with a linear one, find its inverse. A question with an exponential, find its inverse. Okay, let me leave you, and let me give you a hint. It's called bra bar. So the rules start the same. Drop the G of X, right? Y equals 2 to the X. Swap the X and the Y. And now solve for Y. Get the Y alone. Okay. But my discussion all night, the Y is an exponent. How do you move something? How do you get it out of the exponent's place? What do? We have two techniques to do it. The easiest technique is the bra bar rule. That's the easiest, not the only one, but the easiest. So if you do that, remember log base 2, because the base of the exponent and the base of the logarithm are the same. Remember the rule, a logarithm equals the exponent. So it's going to equal the y, because the y was the exponent. Okay, and the only place left for x is there. So again, because Foster has a burr someplace up his whatever, I would expect you to add one more step to this and indicate that this is G inverse of X, showing me that this formula is the inverse of this formula. Okay. Questions? That's almost guaranteed question on the test. I mean, not almost, it is.
The answer also be ln x over ln 2?
2, yes. Because you did it an alternate way. Let me show everybody what the comment was. Okay. And that's the issue. Is there's more than one way at this level of math. There's not always one way to do the problem. God, I wish there was. Math would be so easy. So the question, we were here, y equals 2 to the x, x equals 2 to the y. Okay. Now I suggested that the easiest way is to bra bar both sides, or excuse me, that's wrong. The easiest way is to bra bar this statement. However, I've also taught you that an alternate way is to ln both sides. So that allows you, the ln allows you to move the exponent down. And then if you divide both sides by ln of 2, you have the ln of x over the ln of 2 equals y, which is also G inverse of x. And that becomes a legitimate answer. There is another way, which I'm not going to show you, but there is another way that you could do this. Okay. If somebody wants that alternate way, ask me after class. If you're still awake, if you haven't, fallen asleep. Okay. So thank you for the comment. It was a great comment. It reminds us there's more than one way to take this problem and solve for y. Okay. Well, guess what? We're not done. Finding the inverse. There's a linear equation. Find the inverse. There's an exponential equation. Find the inverse. There is also, what if I gave you a logarithmic equation? But if I said h of x, new function h of x equals log base 5 of x, and I want you to find the formula for h inverse of x. Okay, so take a minute. So we're going to do the same thing. We're going to write this as y equals log base 5 of x. Swap the x's and the y's. And then figure out how in the heck do I get the y alone? How do I get rid of logarithm? Okay. And remember, this isn't log times y. It's log of y. It's a function. It's not log times y. So in my opinion, the easiest way is to bar it again. Bar. So what happens? Well, it's going to be 5, okay, to the x equals y. The base of the logarithm and the base of the exponential are the same. But a logarithm equals the exponent. So x has to be the exponent. And so the only other place y goes is there. So this becomes 5 to the x equals, what was this, h inverse of x. So right there are 3 questions. I guarantee they will come up on Thursday's exam. Find the inverse of a simple linear equation. Find the inverse of an exponential equation. Find the inverse of a logarithmic equation. Now, questions, because we're going to have to erase the board eventually.
Professor, can you
Yeah.
show me how to do the LN method for that?
You on this one, you can't,
Cannot? Oh,
cannot, because it's already a logarithm.
okay.
So, see, this took it from exponential to logarithm. So we wanted to change, and that's where you can use the ln, because the ln is just another kind of log. But this is already a log. You're stuck. You must use the raw bar rule to move it out on this one. That's kind of why I like using the bra bar for everything. Then I don't have to go, oh, do I ln both sides? Oh, what do I do? If you just try to use the bra bar rule on everything, change it from exponential to logarithmic, bra bar, change it from logarithmic to exponential, bra bar. The bar allows you to change it back and forth from one form to another at will. So it's kind of like a more useful tool, I think. Okay, anybody else? Okay. Any questions on anything so far? I mean, by now you guys know, at this time in the semester, you guys know I can talk all night long. Yap. And you're probably sick of me, but I want to make sure that you feel comfortable asking me questions about anything. Maybe it's not this. Maybe it's something totally off the wall. Please, if you have a question, ask.
Yes, Professor. Can you go over some of the word problem, word problem questions?
Yeah, I can do that.
Thank you.
Okay. I actually, believe it or not, was prepared for that. Haha. For once in my life. Okay, let's see. Boom, boom, boom. Boom. Okay. So here's a nice little word problem. I give you the compound interest formula. Where's my pencil? This compound interest formula here. I'm actually telling you what they are. We've gone over that in class. But the question says, Joe invested $570 in a CD. That stands for certificate of deposit, okay, at his local credit union. The rate was 2.7% compounded quarterly, but he was required to leave the money into his account for 5 years. Okay. Take a second. I'll pause this while you guys try and plug everybody in and try and do it, and then I'll do it. Okay. So I've written the formula up here. That's the one I like to use, but if you want to use that PE to the RT one, they're the same thing. It doesn't matter. Okay. And I plugged in A of 5. So in 5 years, when time is 5, our initial amount was 570. This is E raised to the 0.027%. That was the percent as a decimal times 5 years. Okay. So this is just calculator stuff. Let's work it out.
Professor, your camera.
Oh, thank you. Yeah, thank you very much.
Thank you.
Okay, all right. So, okay, talking to nobody. Again, there's the formula. I plugged in 570 for A naught. I plugged in, instead of 2.7%, I plugged in the decimal 0.027 and 5. Do this all on the calculator. Okay, turn it on. 0.027 times 5. Oops. Okay, and then E to that. Okay, times 570. And I get 652.385. Can anybody confirm?
Yes.
Okay, so 652.39, whatever. Okay, so that's the same thing, compounded continuously versus compounded quarterly. Okay, that was pretty easy, I think. Okay, the only question is, can you use your calculator properly to get E raised to that mess? Okay. And if you're not sure, I can try and answer it now. Stick around after class. We can try and work it out together, even though I don't have your calculator. Or make sure you come in early on Thursday so I can help you with your calculator. All right. Now, there was a question, and that is, how long does it take to double? Okay. So this is now a made-up problem. Okay. How long until amount, I'm going to say a sub 0 is doubled? That's the question. How long until the amount you put in is doubled? Well, what that translates to is that someday you'll start at 570 and you'll end up at double 570. Okay, times e to the 0.027 t. So look at what I've written up here. We don't know the time. We're solving for time in this problem. We don't know. We know that that's the interest rate as a decimal. Okay, we know that that's the initial amount, and sooner or later it will double in value. So that's what 2 times mean. Double means 2 times. Okay, so first question to everyone, if I say how long until it's doubled, that would be the equation I would write. Is that all right with everyone? Okay, so here we go. One of the things we talked, well, we want to get rid of the 570. Okay, so we end up with e to the 0.027 t equals, it turns out that will equal 2. If you do 2 times 570 divided by 570, you get 2. Okay, now the question is, how do you solve this problem? And there's 2 ways to do it. Either you can bar it, or you can ln both sides. Okay, I told you that in my opinion, bar is easier, but we can ln it also. So I don't know. I think maybe I'll do both. I'm going to ln both sides. So I'm going to get the ln of 2 equals the ln of e to the 0.027 t. Okay. This allows me, by writing ln, okay, it's going to allow me 2 things. First, I can bring that power down. So I have the ln of 2 equals 0.027 t times the ln of e. So by writing ln on both sides, okay, that allowed me to bring the power out in front. But at the same time, the ln of e is worth 1. So I have the ln of 2 equals 0.027 t. So if I come over here and I get the ln of 2 divided by 0.027, it will equal t. Take this problem here, divide both sides by 0.027. Okay, now whip it on my calculator. This could be a huge number. Okay, 25.672 I was expecting it to be a lot more than that. And this is years. So whatever that is, July, something, it doesn't matter. So, and yes, there will be a doubling question on exam number 3. And it will set up almost exactly like this. You'll have an initial amount. It will equal double its initial amount. And you will have to solve for time. Now, I want to do this one more before you guys ask questions, because I LN'd both sides here. To go from here to here, I took the LN of both sides. That gave me the ability to use my log laws. However, what if I took this same problem and applied the Bra-Bar rule? Okay, so this is exponential, so I know I'm going to turn it into a log. Base E. Remember, the base of the exponential and the base of the logarithm are the same thing. Now, a logarithm equals the exponent. So it equals 0.027t. And so the only thing left for us to do is 2. So that's that's using the Bra-Bar rule to change it from a exponential equation to a logarithmic equation. Okay, now the trick here is, how in the world do you do this? Well, log base E is just an ugly way of saying ln. Log base E and ln are the same thing. So this becomes the ln of 2 equals 0.027 times t. And notice we have that. The two equations are identical to each other. So in this case, it didn't matter which way you did the problem, you're going to get the same equation, same answer. Okay. So solving this problem could have been done 2 ways: ln both sides, or apply the Bra-Bar rule. Okay. Let's take about a 5-minute break and come back. I think pretty much that's it for word problems. Well, there's one more that after we come back from the break, we'll discuss. But let's take a 5-minute break or so, come back, discuss things in a minute. Okay. Everything that we've been talking about since class started tonight was chapter 10. And yes, that's one of the most confusing chapters. Yes, it's what's foremost in your mind, but guess what? Exam number 3 also covers chapter 9. So I want to do some quickie review on chapter 9 also. Chapter 9 started with imaginary and complex numbers. Chapter 9 also included solving inequalities using interval testing. So let's pause right now, give you about a minute and a half to try to get as far as you can on these, and then we'll discuss these and review them. Okay, so one of the first things we learned, if there's a negative number inside of a square root, you instantly, okay, you don't hesitate at all. You take it out and call it I. So inside of a square root, and remember, I only applies to a negative inside of a square root. That's got to be your first step. Take it out. Now, the other thing is we can simplify this. So the square root of 12, you can do it on your calculator, or you can go to your scratch paper. This is 4 times 3. So that's 2 radical 3. So this would become 3 over 2 times I times radical 3. Okay. So one way or the other, you eventually take this original problem, pull the I out, simplify the square root of 12, and you get this. Now, there's 2 things wrong with this answer. First, in your final answer, you can't have an I in the denominator. So we got to get rid of that I. And we know from previous chapters, in our final answer, you can't have a radical in the denominator. So there's 2 things wrong with that, and we got to fix them both. The first thing is if we multiply top and bottom by I, that will turn this into I squared, and it'll fix the I. But we also have to multiply top and bottom by the square root of 3. Okay, because that's going to get rid of the 3. So what that's going to give us is 3i radical 3 on top. 3i radical 3 on top. On bottom, it's going to give us 2 times I squared times the square root of 9. Okay, I times I was I squared, radical 3, radical 9. Now, I totally accept that you guys could be taking shortcuts, taking, not as many steps, but I'm trying to explain this. So remember, I squared is worth -1. Square root of 9 is worth 3. So we have 3i radical 3 on top over -6 on bottom. 2 times -1 times 3. Only thing wrong with this, it also reduces just a little bit more. Normal fraction reduces. 3 over 6 reduces to 1 over 2. The 3 and the 6 reduce. So a final answer for this problem would be I radical 3 on top and -2 on bottom, and that would be our final answer. And remember that negative, you could slide it to the top of your fraction or to the middle of your fraction or leave it in the bottom. That's up to you. So again, there's a bunch of different ways this particular problem could have been done, a bunch of ways. Okay. Maybe I took the long way, but there were some things I wanted to show you here. This problem, you can't have an I in the denominator, but here we have a binomial. So to get rid of a binomial, you multiply by what's called its conjugate, 2 plus 3i to top and bottom. Okay, so on top we have, if we distribute, we have 12 plus 18i over. On bottom, look, when I watched you guys do the quiz we did in class and stuff, a lot of you guys really, really botched it when you tried to multiply 2 minus 3i and 2 plus 3i. When you tried to multiply these two together, man, you made some real fundamental mistakes. Okay. 2 times 2 is 4. 2 times 3i is 6i. This does not equal negative 6. I saw so many people. Well, I saw about 4 people, and I'm going, that's too much for our class. 6i is 6i. 6i squared becomes negative 6 because of the I squared. But be careful, 6i is not negative 6. I saw several people make that mistake. Okay, it killed you. 3i times 2, negative 3i times 2 is negative 6i. And 3 times 3 is negative 9i squared. Now we get that negative 1. So this becomes negative 9 times negative 1. Negative 9 I squared is negative 1. So this becomes 9. So what happens? Okay. These two, when we add them together, they cancel each other out. The 4 and the 9 make 13. Okay. The proper way, however, is to split this up because mom and everybody else in the world wants the real part separated from the imaginary part. Remember, mom kept saying, what's the A value? What's the real value? What's the imaginary value? She kept doing that in the homework. A value, imaginary value. So there's your answer. I'm going to come back and do this one in a second. I may need to erase the board. Any questions about 1 and 2? Simplifying with I.
Nope.
Okay. All right. Then we move on to this problem. Okay. Solving this problem, notice it's an inequality, and I had a special way of teaching that was called interval test. So the way we did it is I pretended that it equals 0. I solved, but so in this case, this is a power equation. So I can factor it, x minus 5x plus 4 equals 0. Split it and get x equals 5 or x equals negative 4. Now, I've just skipped a whole bunch of steps. Okay. How I went from here, this step, to here, there's a lot of math there. That's that AC method. That's that easy trinomial. Okay, but how I went from here to here, okay, factor. Back to factoring again. Oh, crap. Chapter 7. When will we ever leave factoring? Never. Okay. Solve the babies. This is it. Now, remember, these are not the answers. These were what are called critical values. Okay. They're just key numbers, but they're not the answers themselves. What I expected you to do was put these numbers on a number line. There's solid dots because it was equal. And then we had to do that new thing called interval test. That's where you look at this and you see, oh, the number line has been divided into 3 sections, from 5 to infinity, from -4 to 5, and from -4 to -infinity. So two numbers, divide the number line into 3 sections. Your job was to pick a random number in each section, plug it into the original problem, and ask if it made things true or false. Okay, so for example, I said I'm going to pick 6. That's what most people would pick. Test 6. It's the next number after 5. It's a small number. I'm going to plug it in here. So I'm going to have something like 6 squared minus 6 minus 20 is less than or equal to 0. I don't know if you guys can read my work over there. That's the math that you're trying to do. 6 squared minus 6 minus 20 is less than or equal to 0. Well, doing a little bit of arithmetic, I believe that turns out to be false. Okay, and you only have to do just enough arithmetic to convince yourself that it's true or false. It's false. Okay, then we move to the next interval, -4 to 5. Well, again, mathematicians are lazy, so the easiest number to test is 0. Plug it into the original. 0 squared minus 0 minus 20 is less than or equal to 0. Well, that turns out to be true. Okay, if we test -5, okay, if you want me to do it, I will, but the answer is going to be false. Okay, now I need everybody's attention. I know the evening's going on. You're going to have to hang with me for a little bit longer. But this is really critical. I keep saying this, and it's like people don't hear me. I don't know what's happening. I feel like that teacher in Charlie Brown, where all Charlie Brown hears is wah, 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 wah. You know, that's probably what you guys think when you listen to me. Wah, 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 wah. Okay. I need to see you get critical values. I need to see this test on the number line, with the words true and false. Okay, that's required. If it's not there, even if you get the right answer, but you leave this off, you're not going to get full credit. I said this from the first day I introduced this topic. Lastly, you need to decide what's true, everything from -4 to 5, and then how do you express that mathematically? And that would be bracket, -4, 5, bracket. So this is your solution down here. So you're going to get credit for 3 parts. Number 1, did you get critical values? Number 2, did you test the critical values the way I have indicated I want you to test them? And number 3, did you interpret your work and get the correct solution from this work? Okay, so that's 2 parts of chapter 9. The imaginary numbers, simplifying imaginary numbers, doing a little bit of imaginary arithmetic, that kind of stuff, blah, blah, blah. Solving an inequality. Now, we did more of these, but I'm just trying to get your brain working. Any questions about either of these before I erase the board? Or anything to just bring up anything that you want to ask?
I have one question
Sure.
about the testing. Is it always gonna be like 4 to 4 or like 2, 4, 2.
Yes, yes. In this course, the true false truths will alternate. In this course, in higher level courses, you're going to be doing more complicated problems. You're going to be using the same technique, and they may not alternate. So I want to be honest with you. In this course, yes, they will alternate somehow. In future courses, they may not alternate. Okay. So just be careful. Take the shortcut, great. Okay. But be careful in the future.
Thank you.
Sure. Anybody else? I'm wondering how many of you forgot interval testing. Okay, we've been so focused on logarithms and inverse functions and all that other junk. I bet you forgot all about chapter 9. Okay, well, there's another thing in chapter 9. There's another couple big things in chapter 9. Chapter 9 has solving my handwriting got really bad over there on the right. This was 3x squared equals 2x minus 5. This is 5 minus 7 times the quantity 2x plus 1 quantity squared equals 54. And this is 3x to the 2/5 power plus 5x to the 1/5 power minus 2 equals 0. Okay, so I'm going to probably give you more than 5 minutes to work on these. On this problem, whatever you do, do not do 5 take away 7 first. Do not do that. Okay, think about what you would do, but you cannot do 5 take away 7. Okay, so let's pause and work on all of these. Okay, so one of the things we learned in chapter 9 was a bunch of different ways to solve power or quadratic equations. Back in chapter 7, we learned only about factoring. And you shouldn't throw that out. Factoring is important, absolutely important. But we also learned other ways. We learned something called the square root property. We learned completing the square, which we'll use in next chapter. And we learned the quadratic formula. And you will get on exam 3 some equations that require you to use those skills. So let's do it. For factoring in the quad formula, the first thing you had to do was make it equal 0. That was the fundamental rule when you were solving a quadratic equation, a power of 2, is it needed to equal 0. Okay. Then A is 3, B is -2, C is 5. So to use the quad formula was x is negative of b, negative 2, plus or minus the square root of b squared, negative 2 quantity squared, minus 4 times 3 times 5, okay, all over 2 times 3. That was the quad formula. I need your attention for a second, please. Look up 2 mistakes people made on the Chapter 9 quiz. First, PEMDAS in here screwed you up royally. Okay. Secondly, the fraction bar extends all the way out to here. Okay. Several people just stopped it there. Okay. And you're wrong. If you go back and look at the formula, the fraction bar is all the way out to there. Go watch those silly videos. They say negative b plus or minus square root of b squared minus 4ac all over 2a. All. The whole thing is divided by that. Anyway, back to here. X is 2 plus or minus the square root of somebody divided by 6. Okay. This is 4 minus, what is that? 60. Negative 56. I better check it because I just got done chastising everybody about you didn't do your PEMDAS right. Be the pits if I didn't do the PEMDAS right. Yeah. Negative 56. Okay. So we're to here. Negative 56. A couple things come up. First off, you can't have a negative inside of a square root. You take it out and you call it I. 2 plus or minus I square root of 56 all over 6. That's the first thing. The instant you see a negative inside of a square root, you take it out and call it I. Now you worry about, whoa, what about 56? Can I simplify it? Can I do the square root of 56? Okay. Yes, I can. It's 2 radical 14. So this becomes 2 plus or minus 2i radical 14 all over 6. And I notice that all of my normal numbers, not radical numbers, but normal numbers, 2, 2, and 6, they can all divide by 2. So this becomes 1 plus or minus 1i radical 14 all divided by 3. Technically, we're supposed to separate this because that's an imaginary number. So we're supposed to get 1/3 plus or minus I radical 14 thirds. You're supposed to separate the real from the imaginary, and that would be your final answer for the first problem. Use the quadratic formula. Get an imaginary number inside or a negative number, which comes imaginary. And then how do you simplify and reduce and stuff? This would be a really, really good question to put on your note cards. Really good question or sample, something to study, and then to do a brain dump. Why? Because, in fact, by the way, let me put all 3 of these would be excellent questions, okay, to have on note cards to do a brain dump with on Thursday, right before the test. Take that as a hint, okay? So had to make it equal 0, had to use the quad formula, had to take out an I first, had to simplify a radical, and then had to reduce. Everything that we've learned is rolled up into that one problem. Pretty cool problem. Good review. Next problem. Okay. Second thing we're going to do is take away 5 from both sides. So we get -7 times 2x plus 1 quantity squared equals 49. Okay. Divide both sides by -7. And we get 2x plus 1 quantity squared equals -7. 49 divided by 7 is 7. Now comes the fun part. Okay. The only thing that's going to get the square off of this is to square root both sides. But that gives us 2x plus 1 equals plus or minus the square root of -7. Remember, when you use the square root property, when you square root both sides, you have to put a plus or minus on the side opposite from the x. The square root and the square power cancel each other. Okay. And you get this mess. Okay, first thing we do is take the I out. So we have 2x plus 1 is plus or minus I radical 7. Okay, we need to get x by itself. There's several ways to do this. Okay, I'm going to show you what I consider to be the cleanest way, but not the only way. If this bothers you, ask me. First thing I would do is take 1 away from both sides. That would give me 2x is -1 plus or minus I radical 7. Then I would divide everybody by 2 and get x equals -1 plus or minus I radical 7, all divided by 2. Okay, then I would get more ink for my pen. All right, so now that's it's empty. All right. I'm not going to do it because I'm running out of boardroom, but you should split this up into 2 parts, the real part, the imaginary part. This should be split -1/2 plus or minus I radical 7 over 2. Okay. Duh, I've run out of room. I'm going to have to erase probably this problem here in order to do number 3. So I'm going to have to erase problem number 1 in order to do number 3. Questions about any of my work, any of my thought process for number 1 or for number 2? Okay, fine. Okay. Then I guess I erase this and we'll see what happens. Okay. So this was one of those weird ones where we did a substitution. We said something like, let u equal x to the 1/5. We pick a new variable, different than the original variable x. I just pick u, and we always let it equal that value of x. Okay, let it equal that. This gives us 3u squared plus 5u minus 2 equals 0. Okay. Hopefully this is solvable. Okay. Again, I'm doing a lot of steps in my head. Okay. But the AC here was -6. Okay, so you had to use the AC, you had to use grouping unless you followed my shortcut methods that I showed you guys a while ago. But I'm pretty sure that this factors into this. Okay, using the AC method and then grouping and all that other nonsense, this factors into this. And then this solves as u equals 1/3 or u equals -2. Remember the trick was set each of the factors equal to 0. 3u minus 1 equals 0, or u plus 2 equals 0, and then you solve each one, and this is it. Okay, we're not done. Our original variable was x, so we need to solve for x. So we need to get rid of u. So we go back. What was u the same as? U was the same as x to the 1/5 equals 1/3. Or u was x to the 1/5 equals -2. Now we've talked about there's multiple ways of solving this. Some of you know that the 1/5 power is the same as the 5th root. So the only thing that gets rid of a 5th root is a 5th power to both sides, giving me, I don't know what that is. X is 1 over, I think it's 283. 1 to the 5 is 1. 3 to the 5, I believe, is 283. Here, this one, you could have done the same thing we did here, or you could just say, hey, wait, why did I just 5th power it? 5th power this side, 5th power this side. Why is that so good? Because a power raised to a power you multiply, that gives you x to the 1st, because those are reciprocals. X to the 1st equals -32. Check that on your calculator. You can't put -2 to the 5th power on your calculator. You can't do that. You've got to put parentheses, quantity, -2 to the 5th power. Okay, -2 with parentheses around it raised to the 5th power is -32. So our solution set is 1 over 283, comma, -32 for this problem. Hey, I had room, didn't have to erase. Okay, chapter 9. There it is. I mean, yes, there'd be a couple more problems, but these are pretty exemplary of what's going to be on chapter 9 for solving. Some complex numbers, like we did, imaginary complex, solving these, Tomorrow night, I'll have a couple more word problems that we'll do, including projectile motion. You know, when you send a rocket up in the air, what happens? How do you find its hours, stuff like this? I'll have a few more word problems. I'm hoping that tomorrow night you guys will come back. I understand I talk a lot and you might have had questions. Come back tomorrow night with questions. First thing I'm going to do, starting at 6:35, is say, does anybody have their own questions? And we'll answer those. Once we're done answering questions, I'll do a couple more problems that I think are important, and then we're done. We may finish way early tomorrow night, but the test is Thursday. I'm done. If anybody has any questions and wants to hang around and ask them, that's great. I'm here, but that's all I have for tonight. So see you guys tomorrow night. Come loaded with questions.
Thank you.
Uh-huh.